Hello again, everyone. I promise I'm not avoiding you. I have things to do and they're not all in the classroom. Today I actually get to sit in on some interviews for a potential new science teacher at Ridgeline. So that's kind of exciting. We're going to pick up where we left off yesterday. The sub left me a note saying you didn't quite finish the video and they said about where you stopped. So I'm hoping that I kind of pick up where you left off and we'll continue moving forward like we normally would. A quick note before we get started. The sub did say that your behavior yesterday was not ideal. Um, Not everybody. She named some specific individuals, and I think you know who you are. And here's the deal, right? I know that it's kind of a running joke that we have, and the thing is I'm okay with it, right? I know how to deal with it. I know that we can have fun and we can still work, but I'm not there. And when a substitute is there, you need to show that substitute respect and do what they say, right? So I'm going to ask the sub to leave another note just detailing how you were. And if these particular individuals are, again, not showing that respect and not behaving, then we're going to have to figure something out. And I might have to go get our principals involved. I really don't want to do that, but maybe I will. So let's have a good day today. Let's do what we're supposed to do. Please and thank you. All right, here we go. So, if I'm not mistaken, yesterday you were kind of in the middle, I'm hoping, of like whiteboard stuff with predicting the formula of an ionic compound based on either the ions present or based on the name. So I wanted to do a tiny bit more practice with that, and then I will let you work on some stuff in this study guide for maybe 20, 30 minutes. And then at the end of that period of time, we'll pick up a little bit with a new topic, not a new topic, but a little wrinkle to all the rules that we're discovering. Because every time you make a rule, there's an exception, right? We'll pick up on that, and then we probably won't get through all of it today. We'll pick up on Monday, and I will be there Monday, I promise. And I'll kind of get a sense of where we're at and what we need to do. But we're making good time. You should know. We're on track to take our test Friday of next week, which means that you'll have Monday, Tuesday of the week after to reassess if that's something you need to do. So for right now, let's go get whiteboards, markers, and erasers so that we can do a couple practice with this so we refresh our memory from yesterday. I'll have the sub pause the video right now so you can go get that stuff. Ready, set, go. Okay, if you're watching this, you should have your whiteboards, markers, and erasers. You're ready to go. Let's do this first example here. We're going to predict the ionic formula for a compound that has calcium and sulfate, so its name would be calcium sulfate. Note that we're dealing with sulfate, not sulfide. So again, the substitute will pause and play here pretty frequently. They'll pause now. Everybody predict your formula. When you're ready, the sub will play the video and you can see my answer. All right. Hopefully everybody had a chance to do it. This is my formula for calcium sulfate. I went through the same process that we did yesterday. Rule number one is determine the charges of each of the ions. Rule number two is swap and drop. So this 2 becomes the subscript for the sulfate ion. This 2 becomes the subscript for the calcium ion. Remember, in swap and drop, we only swap and drop the numbers. We do not carry the signs, the positive and negative. So I got to this point right here where I determined that step 3, these 2 subscripts can be reduced to a simpler ratio. 2 to 2 can reduce to 1 to 1. So that is my final formula. Calcium sulfate, 1 of each ion. Notice that I don't have any parentheses around the sulfate ion. That's because they're not required in this case. But if you did put parentheses, so you had something like this, I'm okay with it. All right, let's do another one. The sub will pause the video. Everybody try this one. Ready, set, go. Okay. Hopefully you've tried it. Here's my answer. Ammonium is a polyatomic cation, one of the few that we're ever really going to work with. It has a +1 charge. The chlorine ion has a -1 charge. Swap and drop. There's only one of each, and so your formula should be simply NH4Cl. Again, that's mine. Parentheses are not required, but if you did, that's okay. Okay, let's do this one. So I will pause the video. Go ahead and try it. Okay, for this compound aluminum sulfide, we have two monatomic ions with a +3 and -2 charge respectively. So our formula becomes Al2S3. Okay, try this one out. Cesium and nitrite. Okay, the two ions here are plus and -1. So a swap and drop here is pretty simple. It just becomes CsNO2. Because there's one nitrite, parentheses are not required, but if you did put them, that's fine. Okay, let's go ammonium and oxygen. Try this one out. And here's my answer for ammonium oxide. The swap and drop results in a 2 subscript next to the ammonium. And because there is more than one ammonium ion, these parentheses are required. It has to be there. The oxygen has only one, so it sits on the outside after the 2. So this is the correct formula, and it's the only correct formula. All right, so I think that's enough practice together. Now what I'd like you to do is turn to page 11. On page 11, there are some additional practice problems, and it's the same process. There are names. Your job is to predict the formula. Follow the rules. Determine the charges of the ions. Swap and drop, only the numbers, not the charges. And then simplify or reduce the ratio if you can. Only do the ones I've circled. This up will pause the video on this screen so that you can, see it. But again, only do the ones that I've circled. Don't do the other ones. In addition, if you have a little bit of extra time, you can also complete any missing circled items on page 10. But that's what we're going to do for the next 20 to 30 minutes. Okay, I'm not sure how long it'll take us. I'll kind of let the sub determine, when most of you are done or when most of you are not working anymore. At that point, you will continue on with this video. So the sub will pause here and you'll continue on. Welcome back. If you're watching this portion of the video, then you have worked on the circled problems on pages 10 and 11. And, sorry, just noticed something there. And we are going to continue on with our discussion just a little bit. If you'll turn to page 7 in your study guides, we are finally ready to discuss the transition metals, which are, as we so lovingly and affectionately refer to them, they are an exception. They've actually been an exception to a few different things for a while now, but we're finally ready to talk about why and what we're supposed to do with them. Transition metals are an exception to this ionic compound rules, both with naming and determining charges. And that's because really number 4 here, which reads, why can't we predict the ion charges of transition metals? We can predict them for just about any other element, but not those. And the answer becomes why? Well, the answer is simple. Transition metals can actually form ions with varying charges. Sorry, let me move my little window out of the way so you can see this. Transition metals can form ions with varying charges. So that's the answer to number 4. So a transition metal could have a charge of +1. The same element could also have a charge of +2. The same element could have a charge of +3. And on rare occasions, the same element could have a charge of +4. It just depends on the element and on the charge, and so there's not really a way to predict it. It happens in varying charges, so we have to deal with it. The way I think about transition metals, I'll I'll show you this video on Monday. I can't show it now just because I'd have to switch over to my Google Drive, and it's annoying to switch on Zoom. But I compared them to the honey badger, and the video I'll show you talks about how the honey badger just kind of does whatever it wants. It doesn't follow rules. It just does what it wants. It's a funny video. You'll like it. But transition metals are like the honey badger. In addition, it's funny, right? Transition metals are an exception. So you're like, okay, so all transition metals are an exception. Well, that's actually wrong. There are actually two transition metals that are exceptions to being an exception. It's amazing, isn't it? So there's only two of them, though. There's only two transition metals. This is number 5, by the way, on page 7. There are two transition metals that are exceptions to this rule that all transition metals are exceptions. And those two transition metals are zinc and silver. So you should be writing this down. Again, this is page 7, number 5. Page 7, number 5. Those two exceptions are zinc and silver. Zinc and silver do not act like the other transition metals. They do not form ions with varying charges. They form ions with a singular charge all the time. Zinc will always form a +2 charge. Zinc will always form a +2 charge. And silver will always form a +1 charge. As far as why, I'm not exactly sure. I remember learning about this in college and becoming exceptionally frustrated. It was never explained to me. It's something I do want to look into a little bit, but I've been busy the past couple days, so I haven't had a chance. But I can get back to you. But for now, they're the exceptions to the exception to the rule. You do have to know these. And so the way I always remembered it was, if you go to your periodic table, and you should do this, by the way, you should go to your back cover and do this. If you go to your back cover periodic table and you find aluminum, what is the charge of an aluminum ion? It's +3. And so what I do is I think, if I can find aluminum, then I can remember what zinc and silver are. If you find aluminum and you go diagonally downward and to the right, you'll find zinc. And zinc is a +2 ion, always. And then if you go diagonally down into the, I said right earlier, I meant left, down into the left, you'll find silver, and silver is always a +1. And that's kind of just how I remembered it. I found aluminum, and then I made this kind of diagonal line, and then I found zinc and silver, and I just remembered zinc's the +2, silver's the +1, so it's kind of like 1, 2, 3 going up the staircase. If that helps, great. If it doesn't, come up with your own way to remember it. We'll get some practice, so hopefully you'll recognize these, but those are the exceptions to the exception. Number 6 says to name 3 other elements that also can form variable ion charges. So here we've got all the transition metals except for zinc and silver, and they form variable ion charges. There are some additional ones, including these 6. These 6 also can form variable ion charges. The most popular that we'll use in here is lead and probably bismuth as well. These can form variable ion charges. So question number 6 says to list 3. If you want to write down all 6, you can. This up can pause and give you a couple seconds to write them all down. This is indium, this is tin, this is antimony, it's thallium, lead, and bismuth. Those are technically not transition metals. They're post-transition metals. That's what they're called. But they also can form variable ion charges. Okay. Now you might be asking, what about these 2? Those are in the same column as nitrogen. Shouldn't they act like nitrogen? You would think, but they don't. They form variable ion charges, and they form cation ions. I should probably preface that, right? And that's not just true with these purple ones. It's true for all the transition metals. They're always going to make cation ions. Remember, metals are good at giving up valence electrons. So even though they can form variable ion charges, it's never going to be negative. They're never going to make an anion. It's going to be positive, +1, +2, +3, even +4, but it's never going to be minus. All right. With that being said, let's try out a few things. Again, page 7, down at the bottom, it says spot the pattern. So it says iron can exist as an ion with a +2 charge when it bonds with a fluorine ion with a -1 charge. The compound is iron 2 fluoride. That's how you read that. Iron 2 fluoride. And the formula is FeF2. You'll notice that the rules of swap and drop still apply. The rules are still the same. So this 2 gets dropped over here and becomes the subscript of the fluoride. The 1 gets dropped over here, becomes the subscript for the iron, and we're left with this formula. The rules of swap and drop still apply, so long as you know the charge of the transition metal cation. So here's a little puzzle piece visual. Again, it follows the same rules. The compound itself, the whole ionic compound, is neutral. The total amount of positive charge is balanced by the total amount of negative charge. The whole thing's neutral. The rules of swap and drop still apply. Part B says iron can also exist as an ion with a +3 charge. When it bonds with a sulfur ion, the compound's name is iron 3 sulfide, and the formula is Fe2S3. Again, the rules of swap and drop apply. The entire compound is neutral, but this time iron has a different charge, and so the formula is going to look different than if this were iron 2 sulfide or iron 1 sulfide. You can see that this number here that's written as a Roman numeral, that represents the charge on this metal cation. It does not represent the number of cations, right? Iron 3 means iron with a +3 charge. It does not mean that there are 3 iron ions in the compound. Okay, we'll get lots of practice with this. Again, here's our little visual if you'd like to see that. The overall compound is neutral. The charges are balanced. So turn to page 8 and let's fill in a few things on this page. Number 1 says, what do the Roman numerals represent in an ionic compound? Like I just said, these Roman numerals represent the charge. I'm putting an exclamation point there. Sorry, let me move this window so you can see it. They represent charge. They do not, repeat, not represent the number of ions in that compound. Number 2, transition metals always form cations. They're always positive. I guess there's something easy to remember, right? Okay, now let's take a look at number 3 and see if we can predict some of these charges. We've got copper 1 oxide. So I'll keep this down here for a bit. So rule number 1 when determining an ionic compound's formula, turn to the person next to you and tell them what is rule number 1 when determining a formula. Hopefully you said rule number 1 is determine the charges of the ions. So when we look at this copper 1, what is the charge of that copper 1 ion? It is +1. Okay. Oxide is regular old oxide like we're used to. We check the periodic table if you need to, and its charge is -2. So the swap and drop method should work like always. The 1, or sorry, I should say the 2 becomes the subscript for the copper, and the 1 becomes the subscript for the oxygen. So the formula for copper 1 oxide is Cu2O. And I know it feels odd, right? Because copper 1 oxide actually has 2 coppers in the formula. And that's normal. That's supposed to be that way, right? The 1, the Roman numeral 1, doesn't mean there's 1 copper in the compound. It just means the charge of the copper is 1. Okay. Note that the ionic formula does not have any Roman numerals. Okay, I'm going to write that down. No Roman numerals in formulas. Okay, no Roman numerals in formulas. You want Roman numerals in the name right over here, but you do not want them in the formula. Let's try the second one. It says manganese 4 phosphate. Manganese, not magnesium, so it's a different element. It's transition metal. Okay, rule number 1 is determine the charges. This manganese is a what charge? +4. The phosphate, right? I see the HEE, so I'm thinking polyatomic. So I check the front page. Phosphate, I find, has a -3 charge. So the charges go in these little boxes here. And so now we swap and drop. So the manganese, actually, I'm going to write this a little bit lower so I have a little room. The manganese has a subscript of 3, right? We're swapping and dropping. And then the phosphate, PO4, that has a subscript of 4. So I know I have more than one phosphate, so I'm going to put it in parentheses. And then I'll put the 4 out there. Let me move this so you can see it. So the formula there is Mn3PO4, 4. With the phosphate inside parentheses, we have to have the parentheses there. And there's your formula. Again, no Roman numerals in the formula, only the name. Okay, let's take a look at one more. This is copper 2 oxide, right? We had copper 1 before. Now this is copper 2 oxide. So determine the charges first. This has a +2 charge. This has a -2 charge. So we got +2 and -2. So initially I'm thinking I'll have a formula of Cu2O2. Does everybody think that looks good? Hopefully you're shaking your head. We have the last step, which didn't apply to the other two problems because we couldn't do it, but now we can. Step 3 is always reduce if possible. And we can reduce. Those 2's can be reduced to 1 to 1. So this is the formula for copper 2 oxide, CuO. Okay. And that's it. The rules of swap and drop are still applicable. We just have to know what the charge of the transition metal cation is first, and that is told to us by the Roman numeral. Okay, so I think you're okay. I think you can do this. You're going to go to page 11, and these are some additional problems that you skipped earlier. I would like you to try these out. Okay, these are all either transition metals or some of those post-transition metals that have Roman numerals next to them. Now, one of them I want you to take note of real quick is this one, number 10, which says zinc iodide, right? You might be thinking, hey, zinc is a transition metal. Why is there no Roman numeral next to that zinc? Well, remember, zinc is an exception to the exception. We have to remember that zinc always forms a +2 ion. So I'll give you that hint right here. Zinc is +2 and iodide's +1. Now you can proceed, but we have to remember that. Silver is the other exception to the exception. Silver is always +1. So for the remainder of the hour, I'd like you to work on these ones, these problems here. Figure out the formulas for each of these compounds. Okay, good work today, everybody. I will see you on Monday.